In these two examples, you're going to see ln representing the natural logarithm. And of course, the natural logarithm is just another logarithm. It just happens to be a log base e. So the two logarithms that we tend to work most with is the common logarithm, which is a log base 10. And then you have the natural logarithm here of log base e, where e is that irrational number, about 2.718, something or other. You've seen it in the previous lessons introduced to you. And it's a common logarithm that's used a lot in calculus, although this is not necessarily a pre-calculus leading course. It is usually brought up, though, because it is a commonly used logarithmic base. But the rules still apply the same way as they did when you were working with common logarithms. And basically, if you wanted to write this as a sum and difference of logarithms, you would take this single logarithmic statement, and you can see that the 4x to the fifth is being divided by y cubed. And so that quotient could be rewritten as a difference of logarithms. So you would have the natural log of 4x to the fifth minus the log of y cubed. So now it's just natural logs. This here is a product in here, so this could be expanded into a sum of two logarithms, and those two logarithms would be the natural log of 4 plus the natural log of x to the fifth. Of course, you still have the minus the natural log of y cubed. In these two instances here, you have exponents of 5 and 3 respectively. Those exponents can still be moved in front and made a product. So it's going to turn this one into a 5 times the natural log of x, and that's going to turn this one into a 3 times the natural log of y. And as you can see now, that matches this choice right here. In this one here, you're being asked to contract this into a single logarithmic statement. So first, these multiplications on the logarithms are going to have to become exponents on the x, y, and z respectively. So that's going to turn this into the natural log of x to the 10th plus the natural log of y to the 4th minus the natural log of z to the 5th. This sum here can be rewritten as the product of x to the 10th, y to the 4th. So you have the natural log of that, x to the 10th, y to the 4th, minus the natural log of z to the 5th. And lastly, this difference of the two logarithms could be written as a single logarithm involving a quotient. So that would become the natural log of x to the 10th times y to the 4th all over z to the 5th. And that matches this choice right here. And so that is the end of this problem, and that is the end of this video. If you have any additional questions, please bring them up during our class session.